So this is the first video and this will be on the area problem which is covered in section 4.1. So in this video what we are trying to do is we have say a weird graph of some sort, right? And we want to find the area under that graph. So I mean we know if we have a rectangle or a square or a triangle how to find the area, but if it is a different type of graph like a circle or a parabola, okay, in this case we have parabola, how do you find the area under the graph? And so first of all, what we will do is we'll try to break this area right into four rectangles. Well, you can see that the rectangles don't really cover the area, but still, right? I mean, what you're trying to do is to write using four rectangles and get the sum of those rectangles and get an estimate. Now, I want you to look at the way that these rectangles are created. First of all, we got this distance, the full interval, 0 to 1. Okay, and because we are doing four rectangles, we broke it into four pieces. So this is 1/4, again 1/2 here, and 3/4, and this is 1. And we created the rectangles so that the first rectangle actually, the height of the first rectangle is the right endpoint of this interval. That means you can see the 1/4 here, and the right endpoint is 1/4, and the height at that of the function at that point. So this is a function, the red line is a function. So this is the y coordinate of the function at that point. That is the height of the rectangle. And likewise here the y coordinate of the function is this, and that is the height of the rectangle. And then the y coordinate is that, okay, at the endpoint, right endpoint, and that's the height of the rectangle, and the y coordinate here is like that, and that's how we create the rectangle. So this is called a, so when you sum the areas of these four rectangles, that's called a right sum because we are considering the right endpoints. So let's try to find the area of one of them. So first of all we need to get this distance. As I told you, what you do is we take the full length 1 minus 0 and we divide it into 4. Why do we divide it into 4? Because there are four rectangles. So in general, if you have A and B, if this is like A and this is like B, then you take B minus A and divide by N. And then we generally call the distance, the width of the rectangle, B delta X. So right now let's look at the first rectangle. So let's look at rectangle 1. So rectangle 1, then the rectangle 1 is right here. So you can look at the width is always the same, that is delta x, which is 0.2, and the height is, what is the height? Is the y coordinate at this point, which is sorry, this is not 0.2, it is 1/4, right? Okay, so the width is 1/4, right? And what is the y coordinate? It's the y value at 1/4. Okay, so that will be, so we have the rectangle as 1/4 times f of 1/4. That is the y value at 1/4. Now, what is the y value at 1/4? How do you get that? Well, what you do is we take 1/4 and plug it in the equation, which is x squared. So that is 1/4 squared. So once again, the first rectangle will be the width times the y value of the 1/4, right, which is the height. So this is really the width times the height, right? So let me write it down if you want. Width times, and you do it for all the triangles. So here is the first triangle. So if you go to a second triangle, then the width is still the same, but now the y value is calculated not here, but we have to go to here, and that will be 1/4, 1/4, and that is 1/2. So we need to find the y value at 1/2, which is 1/2 squared, and that's how you get the 1/2 squared here. So likewise, the third one will be 1/4 times, we go up here, and this will be now 1/2, 1/2, 1/2, 3/4, so 3/4 squared, right? And we do that and we get the thing, and then we simplify this. This is easy to simplify. You will get this value 0.46875. How close is that to the actual area? Well, you can see that the actual area under the curve, which is this, is actually much, it's in this case a little bare because it's only four rectangle. It looks quite lower. It's lower than the area of the rectangle. So the actual area of the curve is lower than the area of the rectangle. So if the actual area is A, it's lower than the rectangles, which is, so this is the sum of the rectangles. Actual area is lower than that. Okay. Now let's do it again, but now instead of taking the right endpoints as the height, we are taking the left endpoints. What do you mean by that? So now if you look at here, the first rectangle is not there. Why is that? Because I'm taking the height of the rectangle as the left endpoint, and the left endpoint is 0 here, and the height at 0, because it is x squared, is 0. So there's no height. That means there's no rectangle. Now, so in the second rectangle, what is the height of the second rectangle? This is the height, and what is that? This is 1/4, remember? So this is the value at 1/4, and 1/4 is the left endpoint of this second interval. Okay, so but you can see it's always, now we are taking the y coordinate at the left endpoint of the interval. Y coordinate at the left endpoint of the interval. So let's do the calculation now. So if you look at the area of the first rectangle, that is 0, as I mentioned. Now if you look at the second rectangle, what's the area? Again, it's the width, which is 1/4, still remains 1/4, but it's the f value at the left end. So the left end is 1/4, so it's f of 1/4. We know that is 1/4 squared. So it's a width 1/4 times f of 1/4, which is 1/4 times 1/4 squared. Okay. So like that, we again look at that's the second rectangle. So this is the first rectangle is 0, second rectangle is 0, and then you do to the third rectangle, and when you go to third rectangle, the height is the left coordinate once again, which is now 1/2, right? So you take 1/2 squared, and you do that, and you get another number. Okay, so so this is an equal sign here. So what is that number? So this is the second approximation that we get. We see the left hand point, it's called the left sum. And we know by looking at the diagram that is less than, this sum of rectangles is less than the actual area. So this is, the actual area is greater than that. So this is less than the actual area. So if you look at both the above calculation, the actual area is somewhere between the left sum and the right sum. Now we can do it now by increasing the strips from 4 to 8, and if we do the same thing by using 8 strips this time, we'll get a much better range for interval for A, because you can notice that the A interval here is 0.21875 and 0.46. Now it is 0.273438 and 0.3. If you do 16, you will get this. So you can see as you go on, right, you will keep increasing the accuracy of A. You can see that A is heading towards, so between somewhere close to 0.33, and actually we can show that it is really something like 0.333335. Okay, as we keep on increasing the area, like by considering about maybe 1,000 rectangles. Okay, so the whole idea what we did was we showed in this section that when we have a area under a curve, if you want to find the area, what we are going to do is break it up into rectangles. The more rectangles is the better, and you can break it up either using left or right, or in any other way, but we are just doing left and right now. The left end points are right end points. If you want me later, you can take midpoints, right? Okay, and then you get a left sum and a right sum, and the area is between them, and as you increase the number of rectangles, you get better areas. Okay, and that's it for this video.